Good evening, everyone, and thank you for joining us for tonight's class, where we're going to talk about how to take care of your drip system. So some of the things you're going to want to do for maintenance. And then, of course, when things go crazy, you're going to want to know how to figure out what the problem is and then how to actually do some repairs out there. So let's go ahead and get started on it. One of the things we have to remember is these irrigation systems are mechanical in nature. So that means just like our cars, they need to be maintained. You need to change your oil at regular intervals. You want to rotate your tires and all that sort of thing like that. But just like with our cars, maintenance is going to take care of most of the problems you can have in your irrigation system before they become big problems, or at least you're going to catch them before they become those giant water bills, mainly just by paying attention. So yeah, you can kind of try and save some money and not get your oil changed for a while, but if you push it too far, you're going to find out just how expensive it is to put a brand new engine in your car. That's not where you want to be at, and you don't want to do that with your irrigation system either. I hate to tell you though, installation is only the beginning. These systems are automatic, they're expensive, but that's the problem with a lot of these irrigation systems is without maintenance, plant health can suffer, sometimes to death, especially with these drip irrigation systems. You've got these drip emitters that are putting out the water at very, very low rates, 1/2 gallon per hour, 1 gallon per hour, 2 gallon per hour. It doesn't take much to get inside that system and clog up an emitter. And if you're not paying attention, now all of a sudden your plant goes into stress. And if you let it go too far enough, well, that can be the end of it. The system can deteriorate to the point where replacement is the only option, particularly with drip irrigation systems, because the water works at a lower pressure in a drip irrigation system and the water is moving slower. So I've heard people over the years say with a completely straight face that these polytubing drip irrigation systems will last about 8 to 10 years. That's absolutely ridiculous. That polyethylene tubing is not biodegradable. What kills drip irrigation systems early is bad design, bad installation, and zero maintenance. You put those three things together and you're right. A drip irrigation system is only going to last you 8 to 10 years, where if it's properly cared for, there's no reason for having this system in the ground 30 years after installation. And of course, very important to all of us in the desert here is water can be wasted. We want to make sure we're not using any more water than what we need, because taking more water out of the reservoir that we don't need gets us in trouble, especially with all the issues we're facing with the Colorado River water. And I don't know if anyone's been up to Lake Mead lately, but as you pass over that bridge and you look down at Lake Mead, you see that big giant white ring around there. That was where the water level used to be. So we want to make sure that we're doing everything we can to keep that water up in the reservoir so we can survive this climatological drought, not a water supply drought. We have adequate water for what we need, but the climate side of it, if we're not careful, that system is going to drop down to the point where all of a sudden we have to start imposing restrictions on people. And that's not what we want to do. We want to help you use your water wisely. We don't want to become water cops. So not only do you have an irrigation system, if you're like me, you came to the desert from somewhere else. I just happened to do it a long time ago, where back where I grew up, our concept of irrigation was just waiting for it to fall out of the sky. It worked really, really well. But here we've got these automatic irrigation systems. So we've got our sprinkler systems for our grass. We've got our bubblers sometimes for our large high water use trees. That's an effective way to water those. And even if you're not from here and not familiar with irrigation, when you see a sprinkler head pop up and start sprinkling water on the grass like a rainfall event, it's kind of easy to understand what's going on. But then we have these drip irrigation systems where you have these little black skinny tubes sticking out of the ground. It's a much more alien irrigation system, especially to newcomers. So kind of a start to finish on your components of a typical drip irrigation system is you're going to have, if it's an automatic system, you'll have a controller mounted on the wall or inside your garage. Now where the water supply is coming into the house, that's typically where you're going to make your connection, and hopefully you have a good backflow preventer. That's going to keep the water from, once it goes into the irrigation system, from being able to come back into your drinking water. You want to make sure you have that proper backflow prevention. With this style, we're actually able to install our irrigation valves underground in those boxes so they're protected, and it also means we don't have to look at them. That's one thing about irrigation components. It's mechanical, it's engineering. It's not all that attractive, so we go to great lengths to hide this stuff. I've joked for years that we do these classes where we talk about plants, and if we accidentally mention the words hummingbird or butterfly, we'll get 150 people signed up for that class. When we teach classes about irrigation, how to design it and put it in and how to take care of it, we get 20, 30 people for that class. Plant people get all the glory. Us irrigators are merely tolerated. Because plants are pretty and people like to look at them. Now with the drip irrigation system, it does work at low pressure, so you're going to have a pressure regulator down next to that valve. And because those emitters have very, very small hoses to let out that water at that slow rate, you're also going to have a filter. And we're going to actually show you a real one, so you're just not looking at a picture. Once you leave the valve box, that's where you transition to your flexible poly tubing, and you're just putting in your emitters wherever you need them. And at the end of every line, you want to make sure you have a flush cap that you can access it and clean out that tubing. Let's get rid of our annotations there. Okay, so now for any type of irrigation system you always have your daily irrigation system maintenance, and thankfully we're not all in a room together like we normally do because nobody's giving me dirty looks or throwing anything at me. Really all I'm talking about is just paying attention to what's going on. First thing you want to do is look at the plants. They're going to be great indicators of what's going on with your irrigation system. So you can see the individual, all the different signs of underwatering or underwatering in that fantastic brochure called Landscape Watering by the Numbers. If we were all in the room together, it's why I say it's included in your packet. But it is available both in hard copy from your conservation office, and it's also available in a digital format. But it can be a little bit confusing because when the very brand new leaves at the very ends of the stems out there, when they're wilting in the afternoon, people assume that's underwatering. It's not, it's actually overwatering. Now, if your leaves are turning brown, and especially if they're curling upward, that's definitely a sign of underwatering. But really the way to find out is to use a soil probe. Just a nice long metal rod. It will not push into our dry soil, but it will slide with little resistance through the moist soil. So that way you can really tell what's going on with the moisture level in your soil. Go ahead and look at the ground. So go ahead and take a look out there for leaks. They're pretty easy to spot. We have our desert plants out there, but the yard is not completely covered wall to wall in plants. So you can look for those washed out spots. So even without turning on that irrigation system, we knew we had a leak in that drip line there. So we needed to get in there and make a repair. And also pay attention to when you're starting to notice wet spots and you don't have any plants or emitters there, it's time to turn that system on, go out and find out what's going on. The last thing you want to do for daily system maintenance is just pay attention to your hardscape. So you're going to be looking at your sidewalks, your driveways, your pool decking and patios, and you're going to be looking from any of the staining you'll get from the minerals we have in our water. And the ones we're really thinking about here are the calciums and the salts. So definitely pay attention to your walls and fences, especially if you have sprinkler systems, like in this example. They're just using the rotating big rotor sprinkler heads that rotate back and forth, and they've got them out of adjustment. So every time they get to each side, they continue to turn and they spray that water up against the wall. So now they've got that beautiful colored block wall they have there has now got all those calcium stains on it. But seeing those stainings on your flagstone or your brick patio decking and things like that, you might have a blown emitter out there that's actually shooting water over onto your patio. So it's time to turn that system on and see what's going on. So for monthly system maintenance, no matter what type of an irrigation system you have, this class, when we do it normally in person, it's a 3-hour class. And to try and shorten it up, I took some of the common components out of any irrigation system that you would do for maintenance and put them in the beginning. I just forgot that I broke it up into the individual ones this time. So we're just going to cover them here, and then we'll get into this drip irrigation specific stuff. But these are things you want to do no matter what type of an irrigation system you have. The first thing you want to do is turn the system on. Turn it on in the daytime. We run our irrigation in the middle of the night so we don't lose as much water to evaporation. So you want to actually turn it on in the daytime. Don't go out at 2 in the morning with the flashlight to inspect your irrigation system. The other thing is while you start at the controllers, you want to make sure you have the correct program in there for the season. People do not adjust their irrigation timer programs often enough to account for the changing weather. The old joke is if you don't like the weather, wait 5 minutes, it'll be different. Some weather component will be slightly different from 5 minutes to 5 minutes. But definitely at least 4 times a year, change your watering schedule or even better yet, once a month. So you're going to go ahead and turn the system on. There's another great reason to start at your irrigation controller, and that's because you're standing up and you're still dry and not muddy. So for semi-annual system maintenance, no matter what type of a system you've got, if your controller has a backup battery in there, what that does is that's designed to retain the program information in case the power goes out. So very often in the back of the panel, you're going to find a typical 9-volt battery. Do check with your controller manual as far as what type of battery to put in though. If your controller uses a rechargeable 9-volt battery, every 6 months is too often to do it. And the reason is because the controller is constantly recharging that battery when it has power. What you don't want to do is put in a regular alkaline battery into that controller, because recharging regular alkaline batteries is a bad idea. The other thing you want to do about every 6 months is actually open up those valve boxes with the system running and look for any leaks, clean out any excess dirt, and definitely check those wire connections. So here's a commercial installation of a valve, and it's for a drip system. And let's find my annotate here. So here we have our irrigation valve. Here we have our filter. Now in this case, they're using a very expensive brass pressure regulator. Yours is going to look a little bit different. But one thing you also want to do is check out the wire connections in there. One of the most common electrical failures you'll find in irrigation systems is people do not use the right connectors inside those valve boxes. So what I'm going to do here is I'm going to drop out of our presentation here so I can show you what we're talking about. Let's get up to stop share. There we go. Okay, I got a pretty good sized view on me. Unfortunately, what's going on is many people will make those wire connections inside that valve box with a typical wire nut. These make good wire connections. This is what's going on inside the walls of all the buildings and things like that. But what's done here is the ends of the two wires have just been stripped of some of their insulation, and you put it on and twist it until it's snug. The problem is underground in a box with a lid on it, there is a lot of condensation and moisture in there, so the exposed copper at the ends of those wires will begin to corrode. It's a very, very low voltage signal coming from that controller, so a little bit of corrosion here means the signal never gets to the valve and it doesn't open. What some people will do is they do make a type of wire nut. This one is actually larger than what you would probably use. I use this to pass around so people can see. But these are filled with silicone, and they've got those little flanges there to make sure the silicone doesn't leak out. So this still works like a standard wire nut. You put it on and twist it. The problem with these, though, is if anyone does need to replace that solenoid on that valve, they're going to take this off, replace the solenoid, and then put it right back on. There's no more silicone left in there, so now it's just a standard wire nut. That's why when we train contractors on how to do this, we train them how to use the much better type of waterproof wire connector. These are going to be sold at your irrigation supply stores, not at your home improvement and hardware stores. These are sold under the brand names of either Pentite or Dry Splice. So what's going on here is I haven't snapped this one all the way together, is you bring your two wires up inside there, twist them together. They come with this little copper collar you crimp on there, and then you have a silicone filled cap that you snap it together, which I'm not putting all the way back together, because once you do, you can't take it back apart again. So that means if somebody needs to replace the solenoid, in order to remake that connection, they have to cut this off and then use a brand new wire connector. So kind of what your irrigation valve looks like when you're looking at a drip irrigation valve, if it's installed properly, is you've got your irrigation valve and the water's flowing in this direction. So here's your filter, which is just a mesh screen inside there, and we'll show you that in detail later. And then here's a more typical pressure regulator you're going to see on a irrigation system. So drip irrigation systems are happy between about 20 and 30 pounds of pressure. So that's why we have a 30-pound regulator on there. Also important to note is a flow range on there, though. This one works between 1/10 of a gallon per minute and 8 gallons per minute, which is going to be about the right size for most of your residential irrigation systems. So let's look at some more of the presentation here. Oh, it's down on the bottom. I keep forgetting where the controls move when I'm in and out of the presentation. There we go. Okay, the other thing on here is look how nice and clean this valve box is. Very often over the course of time, these valves get buried in the dirt. The dirt just migrates into that open box. And you don't want your valve buried in the dirt because if you ever have a very small leak inside there, not something you'd pick up because it's not flooding the yard, it's not raising your water bill by crazy amounts. But if that soil is always moist in that area, there's something in your yard that is attracted to moist soil. And it's the whole reason you put in an irrigation system to begin with. That means I'm not talking about bugs or termites. I hope you did not put in an irrigation system for the termites. What's attracted to that moist soil is the roots, especially tree roots. I don't have the sample anymore because it got too old and dried out and crumbled, but I had a sample of an irrigation valve I removed that was completely engulfed in tree root just from a very small leak inside that box. So make sure they're not buried in the dirt. For annual system maintenance, no matter what type of an irrigation system you have, you may want to consider when that backflow preventer was last tested. So the most common type and the most preferred type we see out here is the one I'm showing in this picture. That's this guy right here. That is called a pressure vacuum breaker. So this is an assembly that can be tested. So it does have the ports here where a certified backflow tester can hook up his gauge and trick that assembly into thinking the water's running backwards and make sure it's functioning properly. We do require commercial customers with dedicated landscape meters. They're not serving anything inside, so it's not anything to do with human health or safety. Those are required to be tested every year, and if they don't test them, and we remind them and they still don't test them, we will shut off the water to that irrigation system and lock that meter, and they can't have water for that landscape until they go out and test that backflow preventer and ensure that our system is protected and your drinking water is protected. A residential backflow preventer being tested every year is overkill, but if it's been about 3 to 5 years, you may want to consider having that done. You can usually find a list of certified backflow testers. They are certified by the state with your local water department. One thing about them is call a bunch of them so you get a good idea of what the current rate for testing those assemblies are. Most of your contractors are honest, hardworking people, but there are thieves and crooks out there. So make sure you have a good understanding of what that cost should be. Okay, so let's get into some specific things on the drip irrigation system itself. And one thing you have to remember with drip irrigation systems is they do take more time to maintain. So a bunch of different things are going on here. Number one is the components are more fragile. So you can install a drip irrigation system with hard PVC pipe. It is just more difficult to modify and manipulate later on. Now, instead of just adding in emitters very easily where you want to add in new plants or you need to add in new emitters as plants grow, now instead of just punching in some new holes and connections into that flexible poly tubing, you're cutting out pieces of that PVC pipe, gluing in a new fitting so you can attach a new emitter. So if you don't know where your poly tubing is though, and you're digging some holes in your yard, I do recommend you actually have it on and running when you're digging. So that way, if you accidentally hit it with your shovel, you're going to know right away you need to do a repair and flush that dirt out of there. So the other thing is remember, it is a low pressure system, so the problems can be a lot more subtle. People who have sprinkler systems, if they've ever had a broken sprinkler head, they recognize that right away because they've got a 20 or 30-foot geyser of water coming out of the ground. You do not get that with the low pressure drip systems. So you actually want to take the time to get out there and walk around and inspect it. So for monthly drip irrigation system maintenance, definitely turn the system on and then walk through the yard to check for any leaks or damage to your emitters, connectors, or tubing, and make sure those emitters are actually flowing at the correct rate. Make sure you don't have clogged emitters. Make sure they're not blown and putting out more water than they should. Make sure your emission points are still visible. So you want to make sure you're never letting the water out of your drip system underground. So you can see down under here, you can see that little 1/4-inch tubing that we refer to as spaghetti up above ground so you can see and inspect how the system is operating. If that water is being let out of the system below ground, I know there's some people out there that will tell you to bury those so you lose zero water to evaporation. If that's the case, how do you know if the emitter's functioning properly? Do you wait until the plant is dead and say, oh, I guess that emitter must have gotten clogged up? There are two things underground you do not want in your drip system. One of them is the ground. Dirt is the enemy of a drip emitter. The other thing is remember what in that yard is attracted to moist soil. So make sure you don't get any tree root intrusion into your drip system. If somebody who ever put in your drip system did not bury that poly tubing at the correct depth, it should be 6 to 8 inches below ground. It does have a nasty habit of working its way back out of the ground. That's going to deteriorate very, very quickly in our sunlight, become brittle, and it is a leak waiting to happen. So make sure you get that stuff underground right away. If it's got that shiny crystalline look to it, it's already been degraded by the sunlight. Cut it out and put in a new piece of tubing. And you may want to consider, even the best gardeners out there are going to have plants die. Plants are mortal just like we are. So if a plant dies in June, do you really want to go out at 116 degrees and dig a hole to put a new plant in the ground? You may want to just wait until fall, which is a better time to do planting anyway. It's better for you and it's better for the plant. But do you want that emitter location to continue to run through the summer where there's no longer a plant? Well, that's where this guy comes in. And this guy right there just plugs right into the end of that 1/4-inch tubing, and he's called a goof plug. So you can pick those up anywhere, home improvement stores, hardware stores, or your irrigation stores. So let's go back to that first slide. So if you don't run into any problems and everything's working okay, this monthly maintenance check on your drip irrigation system on a typical residential yard is about a 3-minute stroll through the yard. This isn't going to take a lot of time. If you run into some problems, then you've got the time for the repairs, but just making sure you do a once a month, make sure everything's working okay. You know, you pay a lot of money for these landscapes, and if you put it in yourself, you paid a good amount of money, plus you've got the blood, sweat, and tears involved in putting it in. So actually get outside and enjoy the yard. Don't just look at it from your kitchen window. Okay, so for semi-annual drip maintenance specific to a drip system, you're going to want to make sure the emitters are correctly placed. And one of the things that's going on, and we see this on a very, very frequent basis out there, is when the plants are first put in the ground, those emitters are put on the original root ball from the nursery container, which is the right place to put them. That's where the roots are. One thing you want to focus on when it comes to irrigation, stop thinking about watering plants. You're not. The thing that you're watering with your irrigation system is the roots. And once you make that transition in your thought process, how we tell you to do these things all of a sudden makes a lot more sense. So here we've got on a commercial site, I took a photo of this because it was so wonderful. The designer who did this irrigation system knew that nobody was going to move those emitters out away from the base of the tree, and they were not going to add more in as it grew. Because as that tree gets bigger and bigger and bigger, it needs more water delivered to it when you water. So he actually specified he wanted 6 4-gallon per hour emitters. And what he wanted was one of them right at that original root ball, where that container came from the nursery. And he wanted the other 6 spread out here, where the future edge of that canopy of that tree is going to be, what we refer to as the drip line. So while you're waiting for that tree to grow and you're irrigating out in areas 10, 15 feet away from the tree, you could argue that you're wasting water because during the first couple of years, you're watering in an area where the roots haven't gotten to yet. I work in water conservation, but I live in the real world. Nobody moves those emitters out. Nobody adds them in as time goes on. So in our design and installation class, we tell you to put them in at the time of install. Now, on a residential scenario, what you can do is if you don't want those outlying emitters to be watering until the tree actually needs them there, don't forget about those goof plugs. You can just temporarily cap them off. Later on, clip off your goof plugs, put your emitters on, and you're in business with the right amount of water in the right place for that tree. And you didn't have to do any more digging. Unfortunately, the person who did the install did not quite understand the concept of what he was supposed to do. So what you see here is 1, 2, 3, 4, 5. Emitter number 6 was right around the backside of the trunk of that tree. So He did put in the right emitters, but he certainly didn't look at the installation details and put them in where they were supposed to go. So the other thing that's going on here is, do you see that nice little white ring on the trunk of that tree? It's called the Salt River for a reason. There is a sodium content in it. So fortunately, that particular species is pretty salt tolerant, and it hasn't been killed with that yet. Excuse me. Another thing that's going on here is, look at how moist that soil is around the trunk of the tree. So remember, when our soil is dry, it's the consistency of concrete. Before we want to dig a hole, we know to get it wet so it becomes plastic and pliable. Where the tree is anchored to the ground, would you prefer the texture of concrete or the texture of Play-Doh? This is why trees fall over. This is why every time we have a storm, you look at the evening news and you're going to see some poor weather guy out there or weather person out there standing next to a tree laying on the ground. So what you do want to do is water at what we call the drip line. Now you also want to do this with the shrubs, but I'm really using trees as the example because it's a lot more obvious. So this is where the water absorbing roots are. All the water absorption on your woody shrubs and trees happens at the very ends of the roots. And that's what you want to encourage to grow deep and wide, because the roots are what bring up the water and the nutrients. They're also what hold the tree upright in the ground, even in our big windstorms. So even with your shrubs, though, you want to do this because not only is it the right place to water, they're also easier to inspect and repair if they do get clogged up. We have a program at the town of Gilbert where I work at the Water Conservation Office. Much like Chandler's program, we call ours the Water Efficiency Checkup Program. And we go out there and take a look at people's irrigation systems and let them know if there's anything wrong they want to take care of. And I'm not going to start digging around in every individual shrub playing Indiana Jones looking to see if those emitters are working or not. All I'm listening for is if there's a leak going on under there. If I don't hear a leak, one of two things is going on. The emitter's functioning properly, it's not the right place to water, but the plant is getting water from there. Or the emitter is clogged up and it's one of those super bulletproof plants that actually live on rainfall once they become established. So here we have our tree, and at the very beginning, you want to water right on top of the container that came from the nursery there because that's where the roots are. But as time goes on, about every 6 months, keep moving those emitters further and further out to keep up with the edge of the tree. If you think about it, people on their own, if you're out in the middle of nowhere and it begins to rain, people will automatically gravitate to underneath the trees. That's not because it's wetter under there, it's drier. So what's actually happening is the tree is doing its own version of water harvesting and shedding lots of that rainwater to here and to here at the edge of the canopy. So in nature, the majority of your roots are going to be found, as far as the water absorbing roots, are going to be found in those locations. The more you mimic nature with your irrigation system, the more successful you will be with your tree. So they get used to the idea of these trees falling over every 5 to 10 years because we don't grow roots, which means you never get the actual result out of the tree that you're after, and that's shade. So what happens if, yes.
I'm sorry to jump in. There's a quick question. I believe it was in reference to the slide with the tree with the 6 drip emitters. The question was, why not just cap them until needed? The ones that are out further when you, I'm assuming the question was referring to when you first plant it and you
Yes.
have the 6.
When you first plant, yes, when you first plant them and you have your emitters out here where they're not needed until the tree grows there, remember those goof plugs that we showed you? That's what you're going to put in those locations until the tree actually gets out to the point where it's going to utilize the water from there. Whereas in this scenario, they're just completely in the wrong place where they were all put right up on the original root ball and never moved out.
Cool. Perfect. Thank you.
Mm-hmm. Okay. So what happens if we don't move them? Well, sometimes the trees ignore our foolishness and they ignore those emitters that are still right up at the trunk and they put out their roots anyway. Sometimes you can get lucky that way. But one of the things about our desert trees is many of them have the adaptation They've evolved over the eons, knowing that rain events in the desert are very few and far between. So what happens is it's during the rainy season, they do all their growth up on the canopy. It's during the dry season, they do the root development. So now you've got all these trees in the urban landscapes out there with 3 2-gallon per hour emitters at the base of it that are never moved away, and they're running 3 days a week year round. You don't have a dry season. So sometimes what you will see happen is this. So that was one of the hybrid Palo Verdes. And that one, when it was standing up, had about a 25-foot wide canopy. Now, this particular one did go down in the rain, but it was a winter rain. There were no high winds involved with this. It was just a nice, slow, steady rain that actually soaked into the ground and saturated it. So when I started walking up to this to take some photos of it, I mentioned to my coworker, boy, they really spent a lot of money on that tree. They put in a 48-inch box tree. How could I know what size that mature established tree came from the nursery in? That's 48 inches, and that's 48 inches. That tree just never bothered to grow roots. They actually tried propping that thing up and tying it back to the ground, but at that point the root system was so destroyed and damaged, it just ended up dying and had to be replaced anyway. So you're going to have a lot more success by taking care of making sure you've got the focus on your watering is on the roots, not on the shrub, not on the tree. You're watering the roots. You'll be much more successful. Here's a couple more examples of that real quick. So once again, I could have taken a tape measure to that and measured 48 inches. Magical. Okay. So for annual drip system maintenance, only once a year, what you're going to want to do is actually flush out those filters. So the water that comes from our water treatment plants is very, very clean. There's nothing in it. However, how many miles of pipe does that water go through before it gets to your house? And how old are some of those pipes? So you can get some sedimentation from our water distribution system out there, and it will clog up your emitters. That's why we put filters on those drip systems. So once a year, you do want to flush them out and actually take them apart and inspect the filter elements. So what I'm going to do is I'm going to drop back out of our presentation so you can actually see what these look like. There we go. So most of your filters are kind of in this configuration. They're what we call a Y filter. And what you're going to do is actually unscrew it. And inside there, you're going to see just a mesh screen. And most of your residential drip systems are using these ones that have a nylon mesh screen. So you can get them in different, what they call mesh, whether it's 100 mesh, 150 mesh, or 200 mesh. You want to make sure you're using 200 mesh screens in there. That way you're protected all the way down to half-gallon per hour emitters. Now, one of the things on this particular filter, when it's installed to be done correctly, it needs to be pointed downward, because that way when we open it up, anything that was caught in that screen will come out with this. If we did it the first way I showed you, everything's going to fall right back in there and go out and clog up your drip emitters. That's why most of your filters out there nowadays, there we go, here's our big display, has this flush cap on top. So what you're going to do is before you open it up, you're going to take this cap off, and then you're going to actually use the valve itself to manually open it. So you're right here and can see what's going on rather than back at the timer. And the water's coming in this direction and you're in front of the pressure regulator. So you're at full pressure and that water is going to shoot right out of that valve box in a big 25-foot geyser. Unless, of course, you're stuck right up against the side of that valve box because somebody who did your install tried to cram too many valves inside one box and didn't have them laid out correctly. If that's the case, when you turn it on and the water hits the side of that box, it's going to fill up immediately with water. And you're going to stir up all the dirt and the leaves and the twigs and the crickets and everything else that lives in valve boxes. And you don't want that dirty water up above your open filter, because then when you turn it off, dirt's going back inside of it. So if your filter is not situated to where it just naturally shoots the water outside of the box, I've got great news for you, especially if you're the pack rat of the house. How many of you have that short chunk of garden hose you won't throw away because it has the good end on it? The thread on these caps for these filters is not pipe thread. That's hose thread. So make sure your spouse sees you carrying that out there. Take off your cap, screw it right on there, lay that other end outside of the valve box, turn it on, get a nice good flush out of it, and all your water's going outside the box, not filling it up with water. And actually, if you use a longer hose when doing this, just have the end output of your hose out in the good water absorbing root zone of a desired tree. So now that once you flushed it out, let me put my cap on so I don't lose it. Now you can open it and inspect the element. And on this particular filter, this is actually a better quality one that we would recommend. That does not have that nylon mesh screen. That's a stainless steel mesh. We never have to worry about anything getting sharp in there and wearing a hole in that screen. On that other one with that nylon mesh, if there's a hole in the screen, this is no longer a filter. It's just a coupler. So these are very, very durable. That is a 30-year filter right there. Okay, let's go back to our presentation here. And shares down here again. Okay. So, yeah, I know it takes a little bit more time to break out and actually show you the live video, but I really prefer to, whenever we can, show you the actual stuff rather than just pictures of it. The next thing you're going to do for your drip maintenance is actually flush out your tubing. This is something that will kill a drip irrigation system in 8 to 10 years. All that sediment that's in our water, those minerals there, will begin to collect and build up inside that tubing. So it's kind of like the idea of flushing out your water heaters every now and again so you don't get all that sedimentation built up in the bottom there. A very common way we see it done on residential irrigation systems is this little fitting right here. We call that a figure 8 closure, and we'll show you a real one. So it's really doing nothing more than folding over and kinking off the hose. A preferred way to do it is to actually install them down underground in this box, but in this case we want to use a threaded cap inside there rather than these fold over ones. These fold over ones, if they're inside the box, you're not going to be able to open them up. So real quick, we're going to show you what to do if you're kind of looking at a overhead view of an irrigation system here. So on this irrigation system, we do have a separate valve for just our shrubs and then a valve for just our trees, the yellow line here. So very typically on your residential irrigation systems, they will do it in one long run, like what they're doing with this tree here. And in this case, we're going to have a flush cap right there. So we're going to open it up and we're going to turn that station on either manually at the valve or at the timer. And if you have not flushed out your system and you've been in that home for multiple years, I want you to be standing over here so you can see what the water looks like when it first comes out of that tubing. You will become a firm believer in flushing out those lines once a year because the water, what first comes out of there looks like a kind of a mixture of kaopectate and chocolate milk. Now that's one big long run on there. However, on our shrub line, we're using more of what we call a trunk system. So here the red line and the red valve for our shrubs. We're coming out to here. Here we have a flush valve. We're also, oops, let's not move that. We are also coming over here to these shrubs and we would have another flush cap there and another flush cap here and another flush cap here. In that scenario, what you want to do is start with the one that's closest to the valve and you only do them one at a time. Don't open all 4 of them at once and turn on the valve because the water is just barely going to ooze out of each one. You're going to do them one at a time, and you do them starting with the one closest to the valve, so that way when you're doing this one that is furthest from the valve over here, you've already flushed out this segment of the tubing by doing it first with this one. So it's going to make it a little bit easier to do it. Now, some of you may have not been able to find where the ends of your drip lines are. That could be because you just didn't know what you were looking for, or it could be whoever installed your system actually buried the ends of those lines out of meanness or ignorance, I'm not sure which. If that's the case and you take a really good look around your yard and you still can't find them, take a view of your house from above like this. Go ahead and turn on the satellite view in Google Maps or whatever. Remember where your valves are. Get my little drawing tool up here so we know the valves are here. And in this case, I would actually look over at this grouping of shrubs if I didn't know where the caps were. I may have wondered maybe they didn't have a way to get that tubing underneath that driveway. So what they had to do is come all the way around here. And maybe that flush cap is in this location. So I'd start digging around in this area trying to find the end of the line. Now in this case, I would have actually found the line, but not the end of the line. So I would have said, okay, let's start digging in this area. These two shrubs are about the furthest away from the valve, so that's another location to start looking to try and discover where the ends of the lines are. It's not guaranteed that's where they'll be, but those are the best places to go look because who knows who did what when they dug up the trenches to actually install the system. We've seen some pretty crazy things out there. So let me show you what these different things look like in real life, real quick. So here is the figure 8 closure that is just folding over and kinking the tubing. So on this, when you want to flush it out, you're just going to slide that down, let that open up, and turn on the system. So we call this a figure 8 closure because if you look at it, it's a figure 8. That's the thing about irrigators. We're engineers. We have no imagination whatsoever. It's a figure 8, and that's what it is. However, like I said, the preferred way to keep this buried and safe underground in those round boxes you can put out there, each one of those will add about $6 to your irrigation system install. So that's why nobody ever uses them. You can't afford that extra $6 on a $5,000 irrigation system. But we like to use these threaded caps down inside the box. So once again, inside the box, these don't work because you can't get them open inside that little box. Now you're way out at the end of the line behind that pressure regulator that dropped that pressure down to 30 PSI. So when you unscrew that cap inside that box, you're not going to get a 30-foot geyser shooting out of that box. The water's going to come bubbling out at a very quick rate, but it's going to fill that little box up in about 3 seconds. So once again, make sure your spouse that calls you the pack rat sees you bringing your little piece of garden hose out there, because the thread on these end caps hooks up to hoses. That's hose thread, not pipe thread. So now I'm down inside the box. I just don't have a box here with me because it's too hard to hold everything. And then we're just laying the end of our hose out there, and then we can turn it on and get a good flush. Do about a good 30 seconds to 1 minute of flushing after you see clean water. Okay, let's get that guy off.
Hey, Jeff, while you're there, there was a question about how do you turn on the valve from the box? I figured you might be able to show them.
Yep, we're definitely going to get to that, and actually I can do that right now.
Okay, I'm sorry.
That's fine. So on a lot of your newer valves out there, my solenoid only has one wire. They normally have two. It just broke off, and I don't want to spend the money to replace a solenoid when I just carry it around and show people in classes. But some of them, like this one, will have this lever here, and it says on and off. So everyone says, oh, well, I should make sure I set that to the on position. No, that's how you manually open the valve independent of the timer. That's what we call manually bleeding the valve on. This is an internal bleed. Now, if your valve doesn't have the ability to do that by turning the solenoid, the part with the wires, excuse me, on many of them, you'll see this big knob in the middle, what we call a flow control knob. And by turning that down, you can restrict how far the valve opens. But then you see this little black screw over here, and I'm going to try and hold it up close so you can see it a little better. This is called a bleed screw. So we turn that about a half to 1 turn off, and you're going to see water spitting out of there. That is called an external bleed screw, and that allows the valve to open manually, independent of the timer. So we're going to cover a little bit about troubleshooting with wires and things like that. So if you've got problems where the valve is not functioning, but you're still able to run it manually by bleeding it either internally or externally, that way you can still get water out to your yard until you can get that, whatever your problem is, fixed. And hopefully we're going to teach you how you'll be able to fix that yourself.
I'm sorry, one more question was,
Sure.
how do I figure out where the main irrigation lines are located under the soil when I have a half-acre property?
Well, the thing is they're made out of either our polyethylene, so it's not like you can use a metal detector, or PVC, so you're not really going to know exactly where they are. So that's one unfortunate thing, that nobody provides on the residential scale an actual, what we call an as-built drawing of how the system is installed. Almost never happens, and that's really unfortunate. What you can do, though, is start making some sketches of your yard. And when you find some areas where some of that piping is, start drawing it in, and then pretty soon you'll be able to just start connecting the dots.
Cool. And one last question real quick.
Sure.
How do we add boxes if we don't have them at the ends already?
It's just a matter of digging it up. They're open on the bottom. They have a lid that can be removed from top, and you're just going to place it right over the top of your cap there, and then just rebury it. Sorry, I didn't bring out an example here. We're adapting as best we can, and I'm doing this on a coffee table with the laptop sitting on a breakfast in bed tray. So I only have so much room here.
That was good. Thanks, Jeff.
You bet. Come on, share. There we go. So again, like I said, as far as the other question about trying to figure out where the lines are, try and do some best guesses as best you can. You know where your irrigation valves are, and you know where your plants are. Do remember that landscapers, even though they're paid to install these systems, they don't like digging any more than you do. They just get paid for it, and they're going to try and dig the shortest distance from point A to point B that they possibly can. So once again, I'm going to kind of look over in that area and discover that line. I know there's some line here. So over the course of time, you'll just be able to hopefully start connecting those dots. Okay, so yeah, there's some. I had to change the color on the screen because I wasn't able to change the color on my drawings here. This is where, as these plants grow, you're going to consider adding in more emitters. Here we've got just a 2-foot diameter canopy plant, but you see the wetting pattern of that one emitter. We're irrigating a good 50% of that root system with one emitter. But as those plants, and especially our trees, start growing, you're going to want to start adding in more and moving them out. And here we've got a fully mature tree here. Now, actually, some of these emitters that are still under the canopy, these actually may be emitters for shrubs. The majority of your water-absorbing roots are going to be out here, but the tree can still have some down under here as well. So I would actually count the emitter for that shrub as partly watering the tree. Hopefully, if it's a correctly designed system, your shrubs and trees are on different zones. This one isn't, this little guy right here just isn't watering as deeply as the ones that are specifically for the tree. So we'll show you in a little bit just how to add in more line for that when we get to some of the repair section. Okay, so now let's get to troubleshooting here, and it's already 50 minutes. So we're going to go through a few of these things fairly quickly. Even with a good maintenance regimen, things will go wrong, and irrigation systems know when Home Depot closes, so it's Friday night at 11 o'clock when you hear the water gushing outside. So some of your more common things here, and these are all included in the handout you received the link for, and that handout is for the full class, so that also has information on sprinklers and bubblers there, is very often when things go wrong with the system, people automatically assume it's a bad timer. That's the part that's above ground. That's the part that people can see, so they always automatically say, must be a bad timer. A lot of times it's either a programming error or the real problem is somewhere else in the system. So a really great one when I worked at Rainbow Technical Service, where I got the anyone in the country could call me toll free when they're having problems with their irrigation. Sweet little old lady was firmly convinced her timer was under some sort of demonic possession because the irrigation stations kept running over and over and over again right after themselves. So the cause on this one is actually a programming error. She put in extra start times. She thought those start times started individual stations. They do not. One start time starts the cycle of all stations in that program, one after another. So in this scenario, she had it set for Monday, Thursday, had 3 stations watering for 15 minutes because that's what she wanted. If she wanted one cycle of those 3 stations to water, starting at 5 in the morning, she would put in one start time of 5 a.m. Unfortunately, she thought start time 2 started station 2, and she thought start time 3 started station 3. So actually, each station ran 3 cycles of 15 minutes, one after another, for a total of 45 minutes. Very common programming error. Another good one is the irrigation runs at strange times. Could be a programming error. Be careful of that AM and PM when you're doing the programming. If you get one of them wrong, either current time or start time, your 5 a.m. start for your sprinklers interrupts your 5 o'clock in the evening barbecue. Or it could be there was a power failure and your backup battery has died and it's gone back to the default program that they put in, always in the number 1 or A program, and they set it up to water every day, all stations for 10 minutes and 1 cycle. And they typically put in, depending on the manufacturer, either a 5 a.m. or a 10 a.m. or 7 a.m. start time there. But when the power comes back on, the controller thinks it's midnight. So it's 5 or 7 hours later when the irrigation actually comes on. So reprogram your controller and put in a new backup battery so you don't have to do that again. Another good one is the irrigation runs longer than the times that are actually programmed in there. This is still a programming error. A lot of these controllers have this percent adjust or water budget feature that runs a percentage of the programmed runtime. So we've got station 1 set to run for 10 minutes, but it actually runs for 20. That means our water budget is set at 200%. Now, your newer versions of timers, I think the manufacturer's got too many complaints about this being a bad timer. The old ones, no matter where you set that water budget, it would not change the runtime displayed. A lot of your newer models, if we change that water budget to 200%, now when we looked at the runtime for station 1, it would now say 20 minutes. But your older ones won't do that, so make sure you're very careful and pay attention to that function. Another good one is the controller doesn't respond to any of the buttons, no matter where you push the dial, how hard you push them. You've had a power surge that has locked up that microprocessor inside there. So what you're going to do is you're going to reboot that controller. There's no Control-Alt-Delete keys on an irrigation controller, so remove the power, turn off the circuit breaker, unplug it, whichever way it is. But what's inside that controller designed to hold the information on the chip if there's no program? Take out your backup battery. 30 seconds to 1 minute, power it back up. 90+% of the time, they fire right back up. Another good one is one station won't stop watering. No matter what you do, I turn the timer to the off position, it still doesn't water. Well, first check for a programming error. Do that, turn the timer off, and then if it stops, then you know it's probably a programming error. But the problem on this one could actually be in the valve itself down underground in the box. We're going to do a real quick explanation of how to figure out what's wrong with the valve. And we're going to actually show you the inside of a valve so you're not afraid of repairing them yourself. So definitely turn the controller off. If it's still running, the problem is your valve, not your controller. Another one is one station won't water. Check your program. If you forgot to put in runtime for that station in any of the programs, it's not going to run. And it could be either an electrical failure. So these valves aren't connected to the timer by wires, but it could also be a hydraulic failure. The valves are actually using the water itself to open and close. So here, check your programming, manually actuate the valve like I showed you earlier, either that internal or external bleed. If none of the stations water, the cause on this one could be a programming error. Always check that first. You're still standing up, you're still dry, you're not tired from digging a hole that you didn't need to dig. If you didn't put in a start time for that program, they're not going to run. Check, it could be an electrical failure or it could be a hydraulic failure. So first check your programming. You're standing up and dry and you haven't had to dig anything yet. If you have a rain sensor on your irrigation system, set that to bypass if you can, or take it out of the loop so your rain sensor's out there. If somebody's been playing with a garden hose, that sensor doesn't know the difference between hose water and rainwater. So that could be the issue there. And then manually actuate the valve. So if the valve doesn't open, is it electrical or hydraulic? Manually activate the valve. If the valve opens, your problem is electrical. If it doesn't open, it's hydraulic. Electrical valve problems, if it will not open, those wire nuts, that is the first thing you're going to look for. That is the #1 electrical failure, especially on residential irrigation systems. What you're going to do is remove that, cut back to clean wire, restrip it, put on a proper wire connection. Oftentimes that'll get it working again. It could be the controller does have a bad terminal and it's not supplying voltage anymore. Not real common, but it can happen. Hopefully, if you have a 6-station timer and you're only using 4 of them, you can move that wire over to an unused terminal, and that way you don't have to buy a new timer just yet. It could be the wiring between the controller and the valve is damaged, or it could be the solenoid itself is bad, that part with the 2 wires coming off. If the valve won't close, it's either a programming error, or another way that controller can fail is it's always supplying voltage to that terminal. It's a very rare condition, but it can happen. Those of you that know how to use your voltmeters, you're going to check between the common and that station terminal and look to see if that timer's in the off position. You should see 0 volts. If you're seeing 24 to 30 volts, you got a bad terminal. So here we got a little drawing of an electrical connection, how these controllers are wired. So we've got valve or station 1, which is connected by wires to valve 1. We've got station 2, which is connected by a wire to one of the wires on the solenoid by there for valve number 2. This is AC, not DC voltage. Same with number 3. Then you've got a terminal here marked C, COM, or common. That wire is connected to one wire of all of the solenoids. So now if you've got an issue and it's only affecting valve or station number 1, it is either this wire, this connection, or that solenoid. However, if it is affecting all of your valves, then you know it's the common wire or one of these connections that is causing your problem there. Help you figure out at least a little bit better where the problem is in the system. When it comes to hydraulic valve problems, if the valve won't open, either the water is shut off, check that first. It may have been you had an irrigation leak that your neighbor noticed and thought, oh my gosh, I better turn that off so he doesn't have a giant water bill. And then they forgot to tell you about it. They were trying to be nice, but check that first. You haven't had to dig anything up yet. Could be dirt or debris in the valve. If the valve won't close, there's some dirt or debris inside that valve, or there's a hole or tear in the diaphragm. So I know we're coming right up on an hour, which is about when we wanted to end this. And we are almost done, because I think about the only thing I have after this is how to make the poly tubing repairs. So on your irrigation valve, people will replace emitters and do things like that, replace sprinkler heads, no problem. But when they have a problem with one of these valves in that box, they say, oh my gosh, I better hire a professional. There's very little going on inside these valves. So like I said, the solenoid, you're going to turn the water supply off first before you do any of this. The solenoid is removable. And the newer ones that let you manually open the valve by turning that solenoid, a little spring-loaded plunger in there is captured so it won't fall out. If your valve doesn't let you manually open the valve by turning the solenoid, that plunger will fall out into the box, so keep an eye out for it. So again, with the water turned off, now we can actually unscrew the screws on the top of the valve. I only have 2 of them here because I want to take it apart quickly. There is a small spring inside here. Don't worry, it's not strong. It's not going to hurt you. Just don't lose it. And then there's a diaphragm. That is all there is to an irrigation valve. So if the valve won't shut off and there's a hole or tear in this diaphragm, turn your water off, take it apart, put your new diaphragm in, put it back together. You're back in business. Good. Okay, so I think we're going to talk about replacing drip emitters here, and then we're going to be all set. Okay. Why aren't my drippers dripping? Single emitter failures. When your emitters clog up, I did not say if, I said when your emitters clog up, it is the nature of the beast. They do clog up. You're going to remove the old one and install the new one. And real quickly before we get too far on this, I'm going to drop back out here and show you. A lot of people have questions about how these drip emitters are installed. Oftentimes what you'll see is this little spaghetti tubing, what we call that 1/4-inch tubing, coming up out of the ground. And this guy on the end here, right there, is the emitter. So now if you've got it installed this way and that emitter clogs up, it's very, very easy to cut that off. Don't pull it off like I did. Cut it back to clean tubing and then just put on your new emitter. But sometimes all you see when you're looking at your drip lines coming up out of the ground is just that empty 1/4-inch tubing. What that means is they have installed the emitter directly into the poly tubing itself. So it's faster and it's cheaper and easier for them because they didn't have to use this extra 1/4 inch connector, which costs about 4 cents. But now when you want to replace this emitter, you've got to remove it. Now that hole I made is too big. You actually want to use a goof plug in there to plug that hole and to make a new hole for your new emitter. Do use a hole punch. These are made to make the right size hole for the emitter. The other nice thing about this is when I'm punching the hole, it stops before it goes through the other side, which is good because often that's where this hand is, so you can grab it and push on it. Now, if I used a nail and it went all the way through, now I have 3 holes and this one's already leaking. So that'll make the hole for my new emitter. So now I'm just going to pop this guy in here, and this is just a different brand, so it's smaller. And then I can put my new tubing on there. And I'm back in business. But if you don't like your emitters down here, the way they're originally installed, when you have to replace them, just by using this little 1/4 inch connector piece, now I can put the emitter up above ground at the end. So that little 1/4 inch connector looks like, well, it was here a minute ago. There he is. I don't know how well my camera will focus on this, but it's just got the 2 barbs on each side. And then if you look through the middle of it, you can see it's got the hole straight through. One real important thing I'm going to tell you about emitters is whatever emitters you're using, make sure they do something called pressure compensation. Whenever you move water through pipe, you lose pressure. That means even on a good design system, that last emitter has less pressure than your first emitter does. So unfortunately, a very common emitter out there, the newer ones have the little colored flags on there. These are called flag emitters. This is a hole in a piece of plastic. The more pressure you have, the more water comes out. The less pressure at the end of the line, less water comes out. A pressure compensating emitter within a range of pressures still puts out that 1/2, 1, or 2 gallon per hour emitter, which is real important when you're using our watering information for shrubs and trees. We'll tell you how many gallons of water to give a plant based on the size. You have no idea how many gallons of water per hour are coming out of that emitter. And it's different for all of them on the line. So you just can't make that translation. Another thing we see very commonly out there are these guys. Let's see if we can get them in focus here. Sometimes the camera doesn't know where to focus. These are called microbubblers. People call them adjustable emitters. These are the ones where you unscrew the cap, clicks at a time, and more water comes out in that spider pattern there. So let's see if I can't get a good focus on them there. There, you can see one of the notches there. You have no idea how much water is coming out of these, and if you put too many of these on there and open them up too far, you have 0 pressure left at the end of the line. Make sure you use pressure compensating emitters. Let's see, share, there we go. Okay, now you know how to replace an emitter, so I'll tell you about the rest of the styles, the rest of the things that can happen. Okay. Single emitter failures, blown emitters. So sometimes they fail on the other side where they're not clogged up, but they're actually failed in putting out way too much water. So once again, remove them and install the new one. No big deal. It's Legos for big kids. Multiple emitter failures. Lots and lots of clogged emitters. Go ahead and cut them all off. It just may be that you got some dirt in the line and it just clogged up all the emitters, and hopefully you're going to be able to flush that line out and then go ahead and put on your new emitters. If that's not the case and you cut all those emitters off and still no water comes out, that's one of the next things we're going to talk about. The other thing it could be is what's called pinch, what I'm referring to as pinch tubing. The whole idea of our irrigation system is to grow roots, and hopefully we're successful with it. Unfortunately, sometimes the tree root grows along where the tubing is and it pinches it off. So what you're going to do is dig between your last good emitter and your first bad emitter and find out where it's been pinched by that tree root. Now that tree root that has pinched off your tubing, do not cut it so it doesn't happen again. Reroute the tubing further away from that root so it doesn't happen again. The tree root holds the tree upright in the ground. Don't be going out there cutting the roots of your trees. Bad idea. Okay. So the other thing we can have out there is multiple blown emitters. All the emitters are flowing too high. We know they're pressure compensating, but even still the pressure's way too high, or they're even popping off the ends of those 1/4-inch spaghetti lines. Could be a faulty pressure regulator, or unfortunately, many times we see these drip systems put in improperly where they don't have a pressure regulator. So if that's the case, you're going to want to install a pressure regulator, or you can actually test it to see if it's actually operating. And real quickly, I'm going to show you why it's a real great thing to use those threaded end caps instead of those figure 8 end caps. To test what the water pressure is at your house, you can get a gauge that hooks up to your hose faucet. So when nobody's using any water inside, you hook up that gauge and open your faucet, you can see what your static water pressure is in your neighborhood and at your house. So what kind of thread is on the ends of these caps? You can go ahead and put that gauge right on the end of this guy, turn your system on and say, my gosh, I'm at 70 pounds of pressure. Go look inside your valve box. Either you have no regulator or it's not functioning properly. So I think the last thing we're going to talk about here, and it's just going to take me a moment, is repairing the poly tubing. Yep. So now instead of going through all the individual steps, I'm going to switch back to the camera and just walk you through it. And it'll take just a couple minutes because this is the very end of what we're doing here. Okay, one of the great things about poly tubing is, like I said, it's very easy to modify, add in more emitters when you want. It's flexible, so we're not stuck in those rigid right angles the way we are with PVC. So you can get the nice specialty poly tubing cutters, and they do work quite well. Cut off that tubing wherever you want it. Most of us just use our pruning shears, though. Let's go ahead and... time to sharpen my pruning shears, apparently. So now when it comes to doing the repair with the coupling, or adding in more tubing, we're going to use what's called a compression coupling. So all it is a coupling that is slightly smaller than the size of the tubing. So we're just going to scoot up here a little bit so you can see me do it. I'm going to line it up, and with a little bit of a rocking motion, we're going to force that tubing into that slightly smaller size hole. This is Legos for big kids. No glues, no torches, no saws. You don't have to get the tubing inserted all the way to the middle. Just make sure you get it about 1 inch in. Now this does take some force to put in. Make sure you don't accidentally kink the tubing when you're trying to do this. You've got to cut that piece out and put in a new piece because that tubing remembers that kink. And as you're refilling the soil in there, it will kink back up. And you wonder where you don't have the right amount of pressure down there. So it does take some forearm and some grip strength to put this together, especially when you're working down inside that trench trying to put it together. Do not spray this with WD-40. WD-40 was designed to be used as a solvent for cleaning aircraft parts, but the carrier they use is slippery, so it works well on our squeaky hinges. Over time, it will eat through your tubing. Petroleum jelly, well, now your fingers are just so lubed up that you really can't hold this stuff to put it together anyway. If you're able to warm the tubing up, either bring out a cup of warm water and stick it in there for a moment or so. That way it'll become flexible and pliable and easier to put in there. The other thing you can do, I can pull that back out, you'll see actually I've slightly made the end of that tubing a little bit smaller, almost like I ran it through a resizing die. Another thing you can do is use a different coupler. I really need a bigger table for this. Where did my clippers go? Oh, there they are. I'm going to cut off to a new length here. There is a fitting out there. This is made by Rainbird. It's called the Easy Fit coupling. This does not work by shoving the tubing into a smaller size hole. It works by those white pieces will pop out inside there when you turn the system on and grab the tubing from the inside, like the old finger handcuff trick. And you can, with 2 fingers and a thumb, 2 fingers and a thumb, put that together. That's all the force that's required. Now notice I'm not actually putting it together, because once you put these together, you can never get them in there again. Now, because it grabs it from the inside, make sure you've got a clean, straight cut. Don't have old dull pruners out there, where in order to make your cut, you kind of got to chew your way through it. And now I've got that ragged edge on there. As soon as I turn that on with that Rainbird Easy Fit style coupler, I've got a leak going on. So nice, straight, sure, clean cut. One last thing on the tubing here is for elbows and T's to go in different directions. Don't bottom out your tubing all the way to the bottom of the T when you're putting it in there and wonder why the water isn't getting out in that direction very well. You might laugh, but I've seen it happen. So one last thing, well, I did talk a little bit about adding in more spaghetti to move those emitters out further away from the tree. So all I'm going to do is I'm going to cheat and I'm just going to pull it off, but you really want to cut it off. Uh-oh. That's where you use those little 1/4-inch connectors. So now I can attach that on there. And then I can just add some more line to it as much as I need. Now, if I really need to go real far with it, I will actually put in a T-fitting and use some more of the full-size poly tubing to get where I need to go. But if I need to go another 5 or 6 feet, I can add that in and it'll work just fine. That being said, I think we're at the end here, which is about 1 hour and 15 minutes, a little bit longer than I intended. Push it in, don't kink it. Get about 1/2 inch or more, don't push it in too far. Flush the system, never use WD-40, it's a solvent. Warm the tubing up, lay it in the center, immerse it in water. So you may need more help. Don't forget about the irrigation supply stores. I have nothing against the home improvement stores. I can buy products there. I know which ones to buy, which ones to avoid. But going to an irrigation supply store, you're going to be able to talk to people who have worked in the field on irrigation. Some of those guys at the Home Depots are really, really smart about irrigation. Others, when I hear the advice they're giving out, it makes me think they're really, really good at repairing toilets. So your irrigation supply stores are Ewing, Horizon, Site One, and Sprinkler World. And all these stores have branches all over the entire valley. So just use your favorite search engine for irrigation supply, whatever city you're in, and you're going to find one. The other thing you can do is the irrigation manufacturers' tech support lines and their websites. So Rainbird's easy to find, rainbird.com. Hunter is hunterindustries.com. Hunter.com seems to be a financial services company. Toro is easy at toro.com. Irritrol is irritrolsystems.com. Now this company used to go under the name of Hardy. It's the same company, they just changed their name. So if your product says Hardy on it, go to irritrolsystems.com and you can find information on it. Find information on your sprinkler nozzles, your drip emitters, are they pressure compensating or not? You can download the manual for your timer there because most people don't have it anymore. With that being said, I hope we were able to at least get you a little bit more clued in on your irrigation system. So that way, if something does go wrong, you're not going to be terribly freaked out. And we'll go to our last little slide here and turn it back over to Drew.
Awesome. Thanks, Jeff. We do have a few questions.
Okay.
The first one is, any recommendations on moving emitters when the canopy is over the sidewalk and driveway?
At that point, you are going to have to push through to the other side of the sidewalk, or if you already have a line over there, just start popping in emitters on that side. Now, sometimes you don't have the option to water all the way around the canopy. You know, it's over the back wall and into your neighbor's yard. Just hopefully they're doing some watering in their backyard and they're actually watering that side of the tree for you. Just don't tell them. They'll tell you need to give them money for their water bill, when you can just point at their tree and say, well, I'm watering this side of your tree anyway, so it works out. So getting underneath sidewalks, the best way to do it is to dig your trench to each side of the sidewalk and do what we call water jetting. So you're going to buy a fitting that allows you to attach a piece of PVC pipe to the end of the garden hose. You're going to lay it down inside that trench, turn on the water full blast, and start poking at that soil underneath the sidewalk. Make sure you're poking in the right direction and also at the right elevation. Don't start poking down towards China and wonder why you haven't gotten to the other side. Driveways, hopefully there's already a sleeve there somewhere. If not, do not try that water jetting trick because you'll remove so much soil underneath that driveway. The first time you pull your car onto it, it's going to collapse. So then you've got to reinstall your driveway and then make sure you put in sleeves when you do that so you don't ever have to do that again.
Thank you. Another one was, can we see an electrical valve or valves?
Well, the ones I've shown you here, let me stop the share here. So these are electrical valves. So they are connected by the timer with these wires. Well, what's going on inside here is they're using the water itself to push that diaphragm open and close based on opening and closing this port underneath the solenoid. So they get the signal from the timer of when to open and how long to stay open. And then when the signal stops, that plunger down here closes that port back up, refills that chamber above the diaphragm, and pushes it back down closed. So they do get electrical signal, but they're really using the water itself to move that diaphragm up and down just by opening and closing that little port underneath here.
Thank you. The next question is, when is the recommended time to perform an overhaul of a drip system? Is it during the transition from summer to winter grass, during the winter, during the transition from winter grass to summer grass?
Well, your drip irrigation is watering your shrubs and trees, not your grass, so I don't know that that counts so much unless your lines are running through the grass itself. And if you're not overseeding, maybe that time in the spring is the best time to do it. So that way, when you lay your soil back in, the Bermuda grass will fill back in very, very quickly. As far as doing the other thing, if you're doing a complete overhaul of a drip irrigation system, you may want to consider doing that in the late fall into winter. You're going to be more comfortable. You've got more time to deal with it before worrying about, oh my gosh, I got to get this fixed so I can get some water to the plants because it's 118 degrees. So you'll be more comfortable with it then, and your plants will be more comfortable with it.
Awesome. Thanks, Jeff. And last question is, what is the difference between pressure regulators and pressure valves? What is the difference?
Well, there are kind of two different ways to say the same things. And actually, your general pressure regulator is going to be this piece right here. Just as it starts right here. Let me actually unscrew this guy. So just this part is the pressure regulator. So yeah, a lot of people will call them PRVs or pressure regulating valves. And it really is a valve inside here that's opening and closing, and it's responding to the backside pressure when the system fully turns on. And all it does is it opens or restricts an opening in here. So if there's too much pressure, it restricts the opening, so it burns off that extra pressure through that limited opening. If there's less pressure, it doesn't restrict it as much to allow more of that water to flow through and not restrict the pressure as much. So pressure regulator, or the full official term, would be pressure regulating valve, or PRV.
Awesome. Thanks, Jeff. Let's see. There's another question. I'm not sure if I understand it. It says, still confusing for her, turns upside down and turns what I see in my box. So I don't know if they're talking about the filter being pointed upright, maybe?
Yeah. 99.9999% of the time, your filter is going to be pointed in the upward position. And that's because they have these flush caps there. So hopefully if your system is installed correctly, it does have it like this. There is a company that still makes a filter that doesn't have that flush cap on it. And actually on their install, instead of what I'm saying, have it pointing down, they say to point it sideways. I guess that's because how deep does that box have to be and how much room do you have to get in there and actually manage it if it's pointed upside down like that? But in most cases, the type of filter you're going to have is going to be this guy, and it's going to have that cap up on top that you can open and flush. I hope that helps. I hope that answered the question.
I hope it did. I think that was the last question. I'll just wait, give it another second here to see if there's any other questions.
Sure.
Let's see. Okay, cool. And then there was a question about the different. I just want to make sure everyone. I did type it in the answer, but there's different stripes on the tubes. Is there any meaning to those stripes?
No, it has nothing to do with size, but what it does have to do with, and we talk about it in the design and installation, is you can get this tubing with different colored stripes. So that way later on, it's very easy to know which line you're looking at, whether it's the yellow stripe or the green stripe or the red stripe. Is this my shrub line, my tree line, vegetable garden line, or my succulent line? However many other lines, zones, or lines you may have out there. So that way you're not mixing them up and saying, oh, I planted a new tree. Here's my drip line. Let's put in an emitter. And then you realize it's watering with the shrubs and not the trees. So that's really why you have the color coding on these. Handy feature though.
Awesome, thank you. Yeah, they said they've only seen the blue stripes. I'm pretty sure they have them at the irrigation stores though.
Yes, they do have the other colors. And I think on some of the manufacturers that do the colored lines, they now only do the colored stripes on the larger size rolls. So you can't get like a 50-foot roll with the colored lines on it anymore. But the blue stripe has been around for decades, long before the other manufacturers started doing the different colored stripes. And that's actually why this is a different company that manufactures this coupler, made that one end blue. So if you have blue stripe poly, you would always buy their coupler.
Cool. Awesome, thanks, Jeff. I think that might be all of them. I, again, appreciate the presentation was awesome. And I just want to thank everyone for attending the workshop as well today. And then do you mind putting up that last?
Yeah, I'll put up the last slide again and I'll go ahead and mute myself and I'll go outside and take a break real quick.
Okay, sounds good. Thank you. So here you'll find the city of Chandler and Town of Queen Creek websites for more information and resources and our contact information. When you close out of the WebEx, you'll receive a short survey about tonight's class. Both Chandler and Queen Creek would appreciate it if you just take a minute to complete it so we can use it to improve our classes in the future. Thank you again, and I hope everyone has a great evening.